Welcome to the walkthrough of Assignment 1 Part A for my CS 5254 course in the summer of 2023. The objective of the first part of this assignment is to learn how to create, start, and join Java threads. Videos explaining the structure, functionality, and usage of Java threads appear here, and here. I recommend you watch these videos to ensure you understand how to program Java threads. Naturally, we'll cover these topics in class as well. In this first part of this assignment, you'll use Java threads to create a working Android app called Palantiri Simulator. This app contains a resource manager that restricts the number of beings from Middle-earth who can concurrently gaze into a fixed number of palantiri. If you're not yet a fan of Tolkien's Lord of the Rings trilogy, you can learn more about palantiri here. The Palantiri Simulator app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of this assignment, however, you just need to focus on the following three folders. The Simulator Manager's Beings Runnable Threads folder, which contains the skeletons you need to fill in, as we discussed below. The App Source Test folder, which is a set of unit tests that exercise many Palantiri Simulator features and can be used to help test the functionality you implement for the assignment. And App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app is designed to work with Android API level 33, so you need to select an emulator that uses API level 33. If you don't already have an emulator created, you can create one by clicking on the AVD Manager button in the Android Studio IDE. Nested within the App Source main folder, you'll find many folders and files, most of which you can ignore. In particular, this Android program is structured in accordance with the Model View Presenter, or MVP pattern. Most classes are already provided for you. The relevant concurrent processing is performed in the model layer. If you correctly complete the implementation of the skeletons in the model layer, the app should successfully run to completion without throwing any exceptions. You need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Don't change the overall structure of the skeleton. Just fill in the to-do tasks, and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Simulator Manager's Beings Runnable Threads folder. You'll start by modifying the runnable threads manager.java file. Here, you'll need to complete the to-do tasks in the new being method, which is a factory method that returns a new simple being runnable instance, the run simulation method, which calls a method to create and start a thread for each being, and then calls another method to start a thread to wait for all the being threads to finish, and then blocks until the waiter thread is finished. The begin being threads method, which creates and starts a list of threads that represent the beings in the simulation. And finally, the wait for being threads method, which starts a thread to wait for all the being threads to finish and returns that thread to the caller. You'll also need to update the simple being runnable.java file. Here, you'll need to complete the to-do tasks in the acquire palantiri gaze method, which performs a single gazing operation. And then finally, you'll need to complete the to-do tasks in the student.kt file to set the type field to either graduate or undergraduate, depending on which version of the assignment you're implementing. Obviously, this is a graduate class, so you'll all be modifying the graduate field. Your app will be considered correct if it passes all the unit and instrumentation tests and all beings successfully complete their n iterations. A correct simulation should restrict the number of gazing beings to the number of palantiri. In other words, if there are 4 palantiri in the simulation, then only 4 beings should ever be gazing on the screen at a time. When the simulation is running, the app view will display visual feedback to show palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, then the app title bar labels will appear green when the simulation completes. However, if your solution is not implemented correctly or throws an exception, then red title bar labels will be displayed when the simulation completes. Graduate students, or students who are taking this course for graduate credit, must perform the following additional tasks. Enhance the begin beings thread method in the run threads manager.java file to set an uncaught exception handler that calls the being manager.arrow method to indicate that an unexpected exception EX occurred for thread THR. In general, enhance the runnable threads manager.java file to use Java functional programming features, for example, method references and/or lambda expressions. If you're familiar with the Java Streams framework, please feel free to apply it to your solution, which will make it a lot cleaner and easier to understand. We're not undergrads in this class, so you don't have to worry about the things related to undergrads only, but please make sure you do what's described here. Skeleton code for this assignment is available in my GitHub account. Once you've set up your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. The additional work required by graduate students is clearly marked. There's a set of unit tests in the app source test folder, which are provided to increase our confidence that your implementation is working as expected. It's essential that you use the Android Studio GUI to run these unit tests locally on your computer, as described here, and also shown later in this video. As usual, testing only demonstrates the presence of bugs, not their absence. So don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you should address. Please address any of these issues that apply to your submissions to streamline our programming assignment review and assessment process. This assignment is designed to help you get familiar with writing multi-threaded programs using the Android Studio IDE and core Java concurrency mechanisms. It doesn't require you to program any Java synchronization mechanisms, which we'll cover in Part B of this assignment, or complex Java executor framework and/or Android concurrency and communication frameworks, which we'll cover in later assignments. Now that we've walked through the specifications, let's take a look at the skeleton code that you need to fill in. Start by going into App, Source, Main, Java, Simulator, Managers, and then you'll click on Beings and finally Runnable Threads. So if we finally get to the code nestled way down here in this nesting structure. We'll first take a look at Simple Being Runnable. So the Simple Being Runnable class extends this being class, which you get for free, and it also implements the runnable interface. You simply have to implement a hook method called acquire, palantir, and gaze. And what this method does is going to get a palantir from the palantiri manager, and it'll call the appropriate superclass helper method that's part of being. So if you go up here into being, you can see what some of the methods are. And this helper method will block if there are no available palantiri. If a concurrency error occurs in any of the implementations, null is returned, and then you should immediately call the error method, which will throw the illegal state exception. Assuming that you're able to get the appropriate palantiri by calling that call, then you will gaze at the palantir for the time being, for this particular being, which will block for a random period of time. And then finally, on the way out, you'll release the palantir from this being by making a call to the appropriate being superclass helper method. And one of the key things you need to do when you write this code is you need to make sure that you use a try finally block to ensure that the release method is called even if an exception were to be thrown. So let's go up here and go see what being provides. This is the being class right here. And you can see that it's got a couple of methods that you're going to want to get to know how to use. The most important of which is going to be acquire palantir and release palantir. So those are the methods that you're going to want to call inside the acquire palantir and gaze method, which is that hook method that you fill in. Once again, make sure you call this in the context of a try finally block. Now let's go ahead and take a look at Runnable Threads Manager. You can see that this extends something called Being Manager, which is also provided for you, and that's parameterized by Simple Being Runnable. There's a list of threads, which we call being threads, that's provided for you. And then you need to fill in a couple of methods. The first one is a factory method that will make an instance of Simple Being Runnable. So if you go look over here, you can see that there's a constructor, and you have to pass in a being manager, and that being manager, of course, is easy to get because the Runnable Threads Manager is a being manager. So that should give you a hint about what to do there. Then you have to come down here and you have to implement the run simulation method. This is essentially a template method that's going to do some things, First thing you'll do here is you'll call a method to create and start a thread for each being, and those methods are defined down below. Then you'll call a method that creates and starts a thread that's then used to wait for all the being threads to finish, and you'll return that thread to the caller, and then you'll block here until the thread has finished doing its thing. So let's go ahead and take a look at some of the helper methods that you have to fill in. The first one being begin being threads. And what this is going to do is it's going to call the being manager get beings method to iterate through the beings. And then you'll create a new thread object for each one, and you'll add it to the list of mbeing threads. Graduate students have to go a little further. You have to set an uncaught exception handler for each thread, and that will then do the right thing if an exception is to occur. So after you've done all this stuff, then you go ahead and start all the threads in the list of threads. And here, I recommend you use something like the for each method on mbeing threads to go ahead and start everything up using a method reference. If you know Java streams, please feel free to use Java streams here. It's not required, but it'll make the code cleaner and easier to read. Here's another helper method called create and start waiter for being threads. And what you'll do here is you'll create a Java thread that will wait for all the being threads to finish gazing. So it's basically a waiter thread. And if something were to happen, if an interruption occurs or an exception occurs while you're waiting for the threads to finish, you need to call the being manager error helper method with the exception inside the catch clause, which will trigger the simulator to generate a shutdown now request. So you put that code here. Then you need to start running the thread. You need to start it. If you don't start it, then of course it'll never run. And then the last thing you do is you return the thread, and that'll come back to the waiter up here. And then you'll simply block, you'll join until the waiter has finished doing its thing. There's another method here called shutdown now. You don't have to do anything in this case because that's handled for you by the underlying framework. So that's basically the code that you'll need to implement for this first assignment. It's not a particularly hard assignment, but it's there to really to teach you how to create threads, how to start threads, and how to join with threads in order to wait for them to finish their processing. And if you do everything right, then as you see when we look at the test cases here shortly, the unit tests will all pass and the instrumentation tests will also pass as well. Now that we've walked through the specifications and the skeletons, let's show how to run the tests. We'll start by showing how to run the unit tests. If you come here to App, Source, Test, and you right-click on Tests, then you can go ahead and run the tests. And this will build the project and then go ahead and run the tests. You can take a look and see how the build is proceeding here by clicking on the build window. And of course, everything has to build first. And then once you've done that, then the test will go ahead and run. As you can see here, your goal is to have all the tests be green. They are in this case, not a big surprise, since of course this is my master version of everything, so all the tests work properly. So as you can see here, once you've done that, you go ahead and make a screenshot, and then you'll include that as a file called something like results.jpg in your repository, your GitLab repository, so I can see that you in fact passed the tests. So that's how you run the unit tests. So now that we've showed how to run the unit tests, let's show how to run the instrumentation tests. So we come here under App Source Android Test, and we right-click on that, and we click on Run All Tests. And so what that will do is that will go ahead and start things up and run the device that you've selected. Take a look over here. I've selected it to use a Pixel 6 Pro running API 33. And so first it has to go ahead and build everything. And once it finishes building, it'll go ahead and launch the application and test it. Let me make the window just a little bit bigger. You can pick whatever type of device you want to have in order to do the testing. So now we've got things up and running. And so very shortly, it should start to actually do the tests. You can see it's going ahead and running the tests. This is a pretty cool GUI. As you can see, it'll show what happens when you rotate the device going into landscape versus portrait mode, and things will keep running because we've set the application up to do that. And what'll happen here is you can see everything worked properly. We had 10 beings and 6 palantiri, and it did 10 iterations. It completed all of the tests, and we had essentially 10 threads. And then it goes ahead and runs it again. And I think we do a couple of other things to do some other results just to see what happens when you run it at a faster speed. You can see, look at this now, it's going super fast. One of the things you can do if you want to have fun is you can run the emulator yourself and do whatever you need to do in order to play with different settings. And we'll talk more about that when we get to the class. So that's showing how you can run the instrumentation test. This is just making sure that things work under kind of a torturous environment testing scenario. And as long as it passes the unit tests and as long as everything runs and you get the green results, your solution should be in good shape.